today's Monday. So,
I'll be honest, I forgot until I got to work and I was like, oh, it's Tuesday. So.
Yeah. We've run into this a couple times before on Labor Day or the day after Labor Day. We're competing with back to school for a lot of people.
Yep. Right. And there's probably people who haven't even necessarily gotten back today either. You know, like go on a long vacation for Labor Day.
Yeah.
You know, just go ahead and take the day after and the Friday before.
Yeah.
Make it a long weekend, long weekend.
We're smart.
Yeah. Oh well. Probably cancel next month because I won't be here. And it'll be my turn.
That's September.
October.
Prime.
Doesn't feel like it yet.
But that's like the new fiscal year, though, man.
Yeah.
Got to start out strong. Well, maybe I can talk somebody else. Well, you're going to be at Java 1, so there's not going to be anybody that I can get. So, yeah. Now we're going to have to just place can it.
Because I do not know.
All right.
It's going to be Rotary.
So let's see here. Okay, let's check the live stream real quick. Make sure everything's up.
Maybe I can talk.
Yeah, it's up. Make sure I don't get any feedback. Okay, I think we're good.
Oh, we still got a couple of minutes.
Duplicate that. Oh, according to my clock, we got a couple of minutes. According to that clock, that clock's fast though.
Couldn't help but the parking lot looks really empty right now. So you drive out here like, is the place open?
Yeah. Day after Labor Day. Well, we were expecting it to be a somewhat smaller crowd today. At one point, we were worried that we would just be talking to each other.
If you like, we can leave.
No, we're glad you're here.
Thankful that somebody's here.
Yeah.
There's a full house.
Who's presenting today? Or so you could be in the back and pretend to be different people, run around, ask a question.
Yeah, that's right. Sure.
Yep.
Thank you for that unbiased opinion of our work.
That's right. No, we don't do autographs. I'm sorry.
Come on in. Some people that told me they would for sure be here are not here yet, but we are going to get started here. Yep. Okay. So we're going to get started. This is the NSWCDD Java workshop, formally, also known as the Java Jug. So if that's where you wanted to be, you're in the right place. My name's Andy Neproshk. I'm in A21, and this is Mike Kelly from B Department, who's unfortunately going to be moved to another base here soon. If you haven't been here before, we don't have an attendance sheet. If you haven't been here before, oh, we do. Okay. If you haven't been here before, please sign the attendance sheet and put your email on it so we can get you on the distro list. The presenter today is going to be Mike, and I'm just conducting. We decided to organize this because we wanted to have a place to discuss common issues related to Java and to meet people who are doing similar work and potentially increase software reuse and to improve Java development skills. This is our mission statement, which I won't read to you. We've all heard it several times. First Tuesday of the month, even if it happens to be the day after Labor Day. So the news. So one interesting thing is the OpenJDK has a set of guidelines that they have to follow in their kind of charter, same as we do as a Jug. Well, they want to kind of bend the rules of their charter a little bit and set up a separate secret group that is based solely for researching and fixing security issues. As we all know, Java has a long history of having security problems, and it takes a while to get fixed. And the way that it currently works is somebody finds the security problem, it gets broadcast to the world, so now all the bad guys know what the security problem is until it gets fixed. It takes a while to get fixed, and that's a problem. So what they're trying to do is put up a secret group of people, who most of whom won't even be identified, that will work under different conditions. So when a security flaw is found, you can send it to them, and it won't get broadcast to the world, just to the group itself and any trusted people that are associated with the group. Once it's found, they'll investigate it, they'll fix it, and they'll put out the fix, hopefully faster than it has worked up to this point. At least that's the goal. So it seems like they're trying to set up a bunch of hackers or whatever, but really it's a good thing. Some disturbing news: Oracle's trying to offload EE. It might actually be better for EE, but it's kind of disturbing because if Oracle's trying to ditch EE, there's not much left that they can farm out. They've already dumped NetBeans. They've dumped a bunch of the other things, like Hudson. And now they're trying to shop around for somebody to dump EE on. And EE's a very huge part of Java. I don't know how many of you here have worked with EE, but it's huge. And if they don't give it to the right person who's going to maintain it, things could actually get worse. However, historically, Oracle hasn't been so hot at maintaining it. Now, the really funny thing is, at the same time they announced they're trying to ditch EE, they also announced they're gonna maintain it a lot better from here on out until they can ditch it. So I'm guessing that's to kind of make it more pretty for anybody to pick up. But a funny thing is yes.
Did you mention why they're doing this?
Why they're trying?
Envisioning like a replacement for EE, so they're gonna get rid of this and do some replacement.
No. So the reason they stated for trying to do it is they acknowledge that they've been horrible stewards of it. It's a lot of extra work for them. They don't like seeing, Oracle does not like spending money when they don't see an obvious return. They don't get an obvious return for this, but it takes a lot of work. So their hope is by offloading it, somebody else will pick it up that will be willing to work on it in an open source fashion so that it does stay current. For example, Java EE8 is supposed to be out sometime before Christmas or around, sometime before the end of the year. And Java 8's been out for how many years now? It's like, 3 years, 4 years? So it's literally that far behind, because they should come out pretty close to each other. It should be Java Standard Edition, and then Java Enterprise Edition comes out pretty soon thereafter, that incorporates the new things of the Standard Edition. That hasn't been happening, obviously, because they're 3 or 4 years behind now. So Oracle has caught a whole lot of flack for that, and that's a large part of the reason why they made these two announcements of, hey, we're trying to ditch EE, and oh yeah, we are actually going to fix a lot of the stuff, and we're going to do it by the end of this year. Even though they've been working on this since, I think, April of 2014 on Java EE8, so it's taken them a while. And supposedly they're going to release Java 9 EE by the end of next calendar year. So that's their promise, but we've heard that before from Oracle, so time will tell if that actually happens. And as far as Java 9 stands, the last couple times we met, well, I wasn't here the last time, but the last time I was here, we pointed out that it's getting delayed, and that is because several companies like Red Hat and what was the other one that was contending it? Was it Google? No. Red Hat and somebody else were trying to stop Java 9 from being released for different reasons, but they've all said, okay, we'll allow it to be released. So it should be, as far as anybody knows, it's still slated for a September 21st release. And I imagine that Oracle will keep that because they want to have it out before Java 1, which happens the 1st of October. So they'll want that feather so that going into Java 1, they can be going in on a high note. So I believe, hell or high water, they will push Java 9 out somewhere before October 1st, likely on September 21st.
So were the Red Hat issues technical or business?
The stated one was technical, the real one was business, or what everybody assumes is the real one. Because it does mean a big change it's going to cost Red Hat a lot of money when Java 9 comes out to fix a lot of their stuff.
They didn't like the way that they had done modules for Project Jigsaw. I don't know if you were here when we talked about it, but there was like some by default, if like prevents access unless you specify access. Well, these companies basically they were relying heavily on this sort of unfettered reflection of different classes. So that's why
Right.
they didn't like it.
Yeah, a lot of businesses have used a model where they've kind of abused the internal classes, the sun classes that should not have been used that way. And so with this, they won't be able to do that anymore, and they're gonna have to completely rewrite a lot of their stuff. So that's where a lot of the opposition's coming towards it. So with Java 9 coming out, Eclipse has already started to release their latest IDE for Java, which is called Oxygen. They're planning literally a train of releases. So this is kind of bad news if you're a NetBeans fan, because NetBeans has not made any similar revelations that they plan on doing anything like this. So NetBeans does currently support the beta versions of 9, but as far as the official version, we don't really know. A large part of that's because NetBeans was offloaded by Oracle. But Eclipse is seeing a weakness in NetBeans, and they're trying to swoop in and steal back a lot of the Java share. So they are definitely on top of Java 9 with Oxygen and this time around. Something I stumbled across that I thought was very interesting is the JVM. They're thinking about upgrading it, probably not in Java 10 or maybe 11, but they're thinking about upgrading the JVM to be more multi-core friendly. So they're trying to add a bunch of stuff to make concurrency better, to make it able to split stuff a lot nicer, including value classes or value objects, which some people may not know what that is. So a value object is basically an object that just has data in it. It has no real functions. It might have equals, because you kind of need that for putting it in lists and stuff. So it might have an equals and like a hash map, but no real functions to manipulate the data are stored in it. It's just data. So that's what a value class or a value object is. The thing is the JVM currently handles primitives really well. They go fast. They're able to split it amongst the different cores nicely. So primitives currently work really well, but value objects don't. And there's no reason that they shouldn't. But they don't, because the current JVM has no way of saying, oh, this is a value object. It doesn't have functions. Instead, they make it so you have to instantiate it, so you have to keep it. The JVM has to keep it and assume that there's functions tied to it, which takes a lot more overhead and removes its ability to do some things with it. So by doing this change of adding value classes or value objects, things will, for using that, things will go a lot faster, and I imagine we'll start seeing a lot more people using value objects / classes in the future. Another thing is Java 1 is next month, as I already talked about. It starts on October 1st and goes through the 5th, I think. Both Mike and I were invited to speak again, though there was some confusion with that. And but Mike's not able to go, so I'll be going, and 3 other people that I know of from base are going. So if you have a topic that you really want covered at Java 1, something that you're really interested in knowing about, please email me, andrew.nieproschk, that's NIEPRASCHK, @navy.mil. Please email me with what you really want. I'll see to it that the other people going get that as well, and we'll try to divide and conquer and get what everybody wants. And we will be reporting back on it, and we likely won't be having a meeting in October because of Java 1. I'm and several other people are going to be out there, so we probably won't meet again until November, at which point we'll talk about all the things that we learned at Java 1. And that is the news, but before I turn it over to Mike, I do need to make a special plea. So, as we talked about earlier, Mike Kelly's he's part of the Chem Bio group, and I think we all have heard what's happening to the Chem Bio group at this point. So he is probably not going to be able to stay on the jug board for very much longer, and I can't run it by myself. I tried that once, and it did not go well. So this is a very special plea. We need people to step forward and say, hey, I'd be willing to be on the board for the jug. If we don't, we probably will end up closing the jug down, which would be sad because we've now been going for, I think, is it 4 years or 5 years? Is it only 4? Every time I think it's something I learn, oh, it's actually 1 year more. But we've been going for a very long time. So it'd be a shame to have to shut this down. We really need help, though. I can't do this by myself. It's just a little too much. But if we get like 4 or 5 of us to be on the board, then it's really not that bad at all. We have board meetings usually twice a month, one of which happens after this meeting, and the other one sometime in the middle of the month. And occasionally we have an extra one if we need to. But the board meetings are usually on the clock lunches. We meet some mutual place, which around here means a restaurant. So please consider it. Just being on the board does not necessarily mean you have to talk. Definitely you don't have to talk every month. But we will probably need more speakers too, because I can't be giving the presentation every month either. So please keep that in consideration and let me know if you'd be willing to step up and be on the board. Sooner would be better than later so that we can get everybody up to speed before Mike has to leave. And we're kind of hoping that things resolve and Mike gets to stay. But even if he does, it would be nice to have the extra help. So with that, I'm going to turn the time over to Mike.
So today we're going to be talking about how to use Java with Java smart cards, or not Java smart cards, but just smart cards in general. We're going to talk about how to access the credentials and use those things for like authentication, or potentially some other applications that deal with working with private and public keys. So why am I talking about this? It's because I was in a position about a year or two ago where I actually had to do some code signing, and also I was attempting to work with the Java Web Start, which was it ended up being a failed attempt, but not because I didn't figure out how to use the smart card. It's just because Java Web Start sucks and it doesn't work. But anyway, that's beside the point. Completely different presentation. Basically, when I went to go try to learn how to work with smart cards and how to access the information, work with those, there was basically very little information out there that I could find that was any good. And almost all of them seemed to assume that you could just go in and adjust your user's Java runtime install their JVM install and adjust this file, which this Java security. That's actually part of your your JVM install. So I remember thinking, well, how can you go in and adjust your user's security file? Most of the time, you're not going to have be able to adjust that. So that wasn't going to work for me. And the other thing was that most of the tutorials I saw said, okay, well, start off and put your keys, your private and public keys, into your key store file. And I'm like, well, I don't have a key store file. I got a CAC, I got a smart card, and there was very little information. So anyway, that's why I'm talking about today, because I figured, well, maybe some of you might be interested in this as well. If you ever want to write a Java application that needs some sort of authentication using a smart card, this will hopefully be useful. So I'm going to start off with just a little bit of information about the Java Security API. I don't know how many of you ever actually looked into it. There's quite a lot of functionality there. It's composed of a set of APIs that are broken into two different packages. So you got java.security and javax.security. There's some associated tools like Key Tool. You might have used that to generate a key store at some point. And implementations of lots of different security algorithms, encryption algorithms, decryption algorithms, and some various other things. And there's frameworks in place inside of the security framework for authentication, secure communication, so if you're communicating over SSL, and encryption and decryption. So most of it, at least for me, just makes me like really fuzzy-headed because it's so complex. I mean, I start reading about the encryption and decryption stuff, and I'm just like, oh my gosh, like, just tell me what to write, because I can't even understand this stuff. But it is fairly complex, but it's also very useful if you know how to use the classes, because then you don't have to understand what's going on under the hood as much. So here's some of the important classes. The main one is this java.security security class. This is kind of the centralized entry point for working with the security API. And it has a set, it's one of these static classes where you really aren't working with an instance of it. You're just calling static methods on the security class. But it has a list of providers. And these providers essentially give you different implementations of crypto algorithms, methods of accessing, like, say, a smart card or a file-based key store or some other type of authentication mechanism. They can be very different in terms of their implementation, but they all are kind of providing similar services. The key store is one you're probably the most familiar with. Usually you've seen this in terms of a key store file, which is a kind of a container for private and public keys. But there's also a corresponding Java class for that. And then a key is exactly what you would think of it. It can be either a public or a private key, something that represents a cryptographic key. Some additional classes here, a certificate. These are the things that you see when you open up your Internet Explorer options and look at your certificates. There's tons of them. That's essentially what this is. You've got a public key that has been vouched for by some trusted entity, and you can have chains of these things. So you can have like a very long chain. Oh well, this you can trust this certificate because it was endorsed by this guy, which was endorsed by it can go all the way back to Andy's grandmother, as being the trusted entity. And then some of the other ones here, specific interest to smart cards, is JavaX Smart Card IO Card Terminal, which represents a card reader. And then Terminal Factory is basically how you obtain instances of these card terminals. Now I don't know if you would know this off the top of your head. It depends on how well you know the Java documentation. If you go onto the Java 8 API documentation and look for javax.smartcard.io, you will not find it. It's not there, even though it is part of the official Java 8 JDK. Why is that? I don't know why it's not. But I guess historically it was a separate API, and it was integrated into the JDK at some point. I'm thinking that must be why they still kind of keep it separate. But basically, you just have to search for javax.smart.io API to actually get the documentation page, the Java docs for this. But anyway, this is sort of the main classes you use to access the smart cards and smart card readers that you have currently activated on your computer. All right, so talking about these providers, security providers, basically you've got a provider is an interface that has many implementations, and these things can be configured at the same time. So you might have a provider that gives you access to working with like file-based key stores. You might have one that allows you to access information on a smart card, maybe another one that deals with Kerberos, which is another way of doing authentication on some systems. But basically, these things are all registered with the JVM, and so anytime you want to access any of these security-based services, the JVM basically tries to find the one that will meet your needs the best, and then it'll pull that one up. Now, one that is fairly interesting for us, just because it's going to allow us to access the information on smart card, is this one right here, this sun.security PKCS11 Sun PKCS11 provider. Now you might say, well, wait a minute, it's got that Sun prefix on it, what's the deal with that? I am not sure if that package is gonna change when they migrate to Java 9 or not. Normally when I see a sun dot anything, I'm like, oh, that sounds like it's one of those classes you're not supposed to use. But actually it is one of the classes that is blessed in terms of, yes, you can actually use this. But I would hope that in the future they would move that to an actual Java or JavaX based package. But anyway, that's the one that we got to use. And essentially what this does is it acts as a bridge between your Java code and some sort of native implementation of this PKCS11. So like for instance, how many of you guys have Active Client on your computer? All your hands should go up because everybody's got that. So the Active Client is the native implementation that they use for working with your smart cards. And that's not the only one though. There's actually other implementations out there. One of those I will be using today was called OpenSC, which basically does the same thing. It basically allows you to, provides the drivers and so forth for when you plug in a smart card, being able to pull the information back and forth, making sure that it's secure and all that stuff. But anyway, that's what this class is doing. It's basically serving as a bridge between your Java and the native implementation. So cryptography is another thing that is provided by the security API, and it gives you pretty much anything you could imagine in terms of dealing with cryptographic services. So digital signatures, you can work with those, symmetric and asymmetric encryption, decryption, ability to generate keys, public and private keys. This would be of interest if you were going to work with public key encryption and being able to sign documents and so forth. It also has message authentication codes, being able to determine whether something is actually from who you think it is. And another important piece is the pseudo-random number generators, which is a big deal when it comes to working with encryption and decryption algorithms. So all of this stuff is very complex in terms of, how even trying to read the documentation on how to use the classes can be kind of mind-boggling. It's almost like you do have to know something about encryption and decryption to be able to use them, I've found, because if you don't know anything, you'll end up just kind of lost. But they did do a good job of at least abstracting away as much detail as could be. And I'm not going to go into a great deal of detail with any of that today because that's not really my purpose. But I just wanted to mention it because it is a big part of the API. So you may have noticed earlier I mentioned two different packages for security. So there's java.security and javax.security. Actually, I should have moved that. Basically, that I have a typo here. This should be javax.security. But anyway, the reason is apparently that it had to do with export controls. So the java.security code, you could distribute that to outside the US, but the javax.security you could not, or something. That's why they have them separated. So that might be a slight area of confusion when you get into doing some of this, is that you've got some classes that are in java.security and javax.security. And essentially the cryptographic algorithms are in this javax.security package, and the more general framework classes are in the java.security package. Okay, so in terms of providing cryptography, the algorithms are implemented by the providers. So I mentioned earlier you have these different providers that provide implementations for different security algorithms. Well, each provider provides its own cryptographic algorithms like RSA or DES encryption, and so they've got the same interface basically, but they're implementing them in different ways. And others, like for instance Active Client, might be based on a hardware token, which will, for us is usually a smart card, but it wouldn't necessarily have to be a smart card. Also key fobs, if you've ever seen those, that would be the same sort of deal. All right, so here's some of the cryptographic implementations. Some of these probably look familiar to you. These are all ones that you can use inside of the JVM. All right, so PKCS, that stands for Public Key Cryptography Standards. And the one of interest to us is this PKCS 11, which provides a generic interface to cryptographic tokens. So you basically, like I said, a bridge between your Java code and some sort of native implementation of this, like Active Client or OpenSC. And that Sun class that I mentioned earlier is the built-in provider that Java gives you, is this Sun PKCS 11. And so using that, you can actually access the information on your smart card. And yeah, so here's just some examples of different types of security tokens, some sort of physical device that is used in authentication. Some of the related tools for security is Key Tool, which most of you have seen, and Jar Signer, which is a related tool, but that allows you to sign a jar that you have built, and so that people who receive it can know that, okay, well, this was actually from you. This wasn't just somebody who randomly put this together. I can actually trust the code that's in this jar file. All right. So now, any questions? That's kind of just an overview of the security API. I'm obviously not an expert on much of it at all. Just know what I need to know to get the job done, basically. But I thought it would be useful to go through some coding examples so you can see this in action. Let me switch over to NetBeans here. All right. Everybody read that okay? Let me know if you have any trouble. All right. So the first thing I want to try to do is to have Java tell me all of the available card readers I have attached to my system. Right now I've got one card reader set up, so it should only indicate that there's one available. So what I'm going to do is I'm going to create a new class. Call this determine readers. Put that there. All right, and I'm just going to So I'm going to create a main function here, and really all I want to do is just interact with the that provider, that Sun PKCS provider, and have it tell me whether or not I have any readers attached to my system. So let's just see active card readers. All right. And I'm just going to put a generalized try-catch around this thing because, as you would imagine, a lot of this stuff throws exceptions. Okay. All right, so let's do this then. So in order to get the list of potential, or the list of card readers available, I'm going to ultimately interact with a terminal factory. And the terminal factory basically is able to go out and tell me, which card readers are available. So let me just do this. So I've got it's going to give me one or more card terminals, which is basically a card reader. And I'm going to call the function get card terminals, which does not exist yet because I have to write it. So once I get those, though, I want to basically go in and I want to just print out the name associated with it. And actually, I want this to be a printf. I want to have it tell me kind of the ID associated with the reader and whether or not there's a card currently in it. Okay, so so card reader, get name, and then card reader. Actually, let's get my autocomplete going. Is card present? Okay. So now that's going to go through. Once I get this get card terminals implemented, it'll go through and tell me whether which readers I have available on my system. All right. So let me just do that. List of card terminal, get card terminals, and throws exception. All right, so first thing I do is import, so I create a terminal factory because it's going to basically go out and look for these card readers. Just do a get default. That gives me a terminal factory. And then all I have to do is just say return t factory terminals. And that actually gives me something that I can then convert to a list. Okay. So both of those classes, you'll notice those are from the JavaX Smart Card IO. So those are actually outside the normal documentation for Java, so you might actually have to go and search for that API separately if you want to know more about it. All right, so why is this complaining at me? $in. Okay. Yep. Okay, so let me run this then. Okay. So up here in my output window, it ran and it basically spit out that I've got this card reader set up. And I do have a card inserted in it at the moment. Now I'm going to take the card out. Is that hard? Oh, yeah, let me see if I can, sorry about that. Let me see if I can bump it up. Yeah. I wonder if it'd be better if I just put it down here. Then I can just pull it up when I need it. Yeah, that's probably better. Okay, so right now if I run it again, it should tell me that there is no card in it now. So now it says card inserted false. So if I had multiple card readers plugged in, it would basically list them all. So on my work computer, I basically have two different CAC readers, and one is for like NMCI or regular stuff, and then I got this other one that's kind of a for RDT&E stuff. But anyway, so this is how you get the list of readers that are available. All right, throw that back in there. So once you've got the list of available card readers, then you can actually start to do some stuff with them. So next thing I want to do is actually access the information on the card and list out all of the aliases of the keys. Now, one interesting thing about at least our smart cards that we use here at work is that you can't actually print out any of the private keys. So you can't actually export any of that data to a localized key store, to like a key store file or anything. If you try to do that, it won't let you, which is why all the examples online really suck, because that's what they say. The first step is export your stuff to a key store. So you can't actually do that. And not only that, but you can't even do it in code either. You can't access a private key from your smart card and put it into a variable in code either. That is not permitted. So it makes it a little bit more challenging than it normally would be if you just had a simple file-based key store where you can export private keys and look at them and so forth. So anyway, what I want to do now is I want to list all the aliases on my card here. So let's see, list keys on card. All right, and I'll do the same sort of thing. Let static void main string args. All right, so some of the steps I will have to repeat. So I may do a little bit of copy pasting to save time. Now, one of the things that I'll have to incorporate here is actually the link back to the native implementation that I'm going to be using. So I mentioned that PKCS11 provider, it serves as a bridge. So you've got your Java code, but then it also needs to know, okay, well, what native implementation are you using? I don't have Active Client installed on here. I've got an open source one called OpenSC, but the same sort of deal. And so what you essentially need to know is the location of the appropriate DLL for the type of native implementation you're using. So I'll show you the one for Active Client and for the one I'm using. So for Active Client, it's going to typically be in your C program files / active identity / active client. And then there's this DLL called ACPKCS211.DLL. That's the one that you would use if you were doing this on, your work computer or something like that. Now, for me, I'm using a different one. Let me just comment this one out here, and I'll make this code available to everyone. See, path to native DLL. So for me, it's going to be in C, Windows, System 32, and then OpenSC, PKCS11.DLL. All right, so for the open source implementation I'm using, which is called OpenSC, that's where its implementation DLL lives. So I just have to be able to reference that. All right, so now I've got my static main function. Now I want to try to go start doing what I need to do to actually access what's on a card. All right. So I am going to need that function that I just wrote earlier. So let me grab that. I'm going to need this get card terminal. So I'll just copy that. Now, if I was doing this regularly, I would create a utils class or something instead of just doing a copy paste. But just so that we can see everything on one page, that's why I'm just copying it. So let's write out what are we trying to do here. So we'll start off with our try catch. And first thing we'll want to do is get the list of card slots. And what we'll need to do to be able to access information on a card is we have to install the security providers. Now, every tutorial that I've seen online basically says, now go into your Java installation and update the security.providers file, which means you would go into Java, JRE, lib, and then security, java.security. So there's this java.security file. I don't know if I can make it any bigger, but basically there's a section that you lay out the different security providers. And that is one way to add support for this PKCS11. You'll notice it isn't listed here. It's not there by default. So one way is to go in and modify this file. I think that's a really stupid way to do it because I don't want to have to update that java.security file every time I install a new JRE, right? So I think it's much better to have a way of just doing it in code, when you actually need it. So that's what we're going to do. We're going to basically dynamically update the security providers as part of our program instead of doing it statically. Now, one of the helper classes I'm going to be using is called card slot. I already have that implemented, but basically it's essentially a data class that holds a reference to a card terminal, an index, and a provider name and a display name. So that's really all that is. That's what I'm referencing here. So I will need to implement this install providers method in a second, but let's get on going down the road a little bit here. So for each card slot that I find, which basically the card slot represents an actual smart card. So it sort of assumes I've gone in and grabbed the available cards. All right, so for each one of those, I want to print out all of the keys on the card. And I'm not actually printing the key data, I'm just printing the aliases, So to say that, so I'm not going to get in trouble later. Pulling that in, see. So I'll just pull out this display name, which is essentially the card alias. All right, so for each one of these, so say for each one of these key aliases, I'm going to call this method get card aliases and then pass in the card that I'm working with. Then once I get that, I want to print it out, say, all right, well here's my key. Okay, and then print out alias. All right, so I got to implement a couple of functions here. This install providers and get card aliases. I already have the get card terminals, which I will need. So let's start off with the get card aliases. Actually, let's do the install providers first. That one makes more sense to do first. All right, so let's do static. I want to get the list of the card slots. So install providers throws exception. Okay. So in order to do this, just go ahead and create a list to get my list of card readers. So in order to do that, I need to invoke my get card terminals method. So once again, that's going to get me all of the card readers, whether or not they have a card in them or not. That's just going to return all of the ones that you have plugged in to your system. Now I'm going to use some Java 8 streaming magic. Readers Size. Basically, this is equivalent to a for-next loop with, you know, an increasing index. So I want to map to object. Dang it. Okay. So that'll give me my counter, import the stuff I need. Okay. So for each one of those card readers, I'm going to do a try catch here. Basically want to check to see if there's a card present, and if there is, I want to install a PKCS11 provider for that card. You have to do it based on the actual hardware slot. You can't just have one for all the cards, which seems kind of weird, but that's just the way it tends to work. And so what we're doing is equivalent to updating that java.security file. So we're actually going in and manually updating that in code. All right, so for each one of those, I want to check to see card readers get check to see is card present. So if there's a card present, then I want to create a new configuration for that. So string.format. And this matches actually what you would see in that file, in that security.java file. $1 All right. Okay. What am I doing? Yeah. Plus. And this is a little bit of a tedious part in terms of syntax, because if you don't get it just right, then it'll complain at you. Okay, plus equal to %3 sign D. Let me go ahead and I'm thinking I probably have some errors in there somewhere. So format. All right, so PK. So this is what I'm actually going to call this provider. I'm going to call it PKCS11 with a reference to the index that I'm using. All right. Then I'll use, this is where my path to that native DLL comes into play. So I actually have to tell it, okay, for this PKCS11 provider, use this DLL as your native implementation. So this is where that comes in. For some reason, I guess just because that's the way you normally have to do it with Java strings is you can't just have a single slash when you give the path. You have to give it the // So since I've already created a string out of path to native DLL, and that shows up with just a single slash, I have to actually replace it with basically 2 slashes. So for each for each slash, replace it with 2 slashes. That's all I'm saying there. Okay, so and then comma, then I, and then we'll throw the. Now I get to find out what the heck I did wrong here. Okay, so name is all right. Okay, maybe it's just because I'm inside of a string. Okay, so I got my config. Now let me create a byte array and put stream. Put stream a new byte array. Alright, and I'm going to basically tell it to take the config and get the bytes from that. And I'll just use the default char set for that. Alright, so now I can create this actual provider for this thing. And what I do is I instantiate that PKCS11 class, and then pass in the configuration, and then it kind of does the rest. Sun.security.pkcs11, and then we want to do this one, and we'll use this constructor that takes an input stream, and we'll import it. No, not that provider, we want the security one. JavaX, no, JavaX security, that's the one we want. Okay, so once we have that, then we can add it to this static method add provider on the security class. So I mentioned earlier that the security class is sort of the entry point into using the security framework. It is what maintains the list of providers that are available. So essentially, when you start off the JVM, it's loading in all of the information in that security or java.security file that I showed you. It's loading all that in, but we can actually add to it as needed at runtime, which I think is a way better way of doing this in general. So now we want to do, so now we added that provider, now we just need a way to reference it later. So I'm going to create an instance of my card slot. cp.getName, so we'll give it the provider name, card readers, and tell it, give it the reference to the card terminal that it's based on, and then just the index. All right, so now I get to see what the heck am I doing wrong here. If you guys see the bug, let me know, because I don't want to stand up here for too long. Okay, so what did I do? Map to object. Okay, so I try catch. Just really. All right. You guys get a first-hand look at my debugging skills. All right. Not sure why that get card readers. Yeah, I'm thinking, yeah, you're right. That's what I need. Thank you. That's right. So I just need to tell it to filter out. Yeah, right. I need to throw, yeah, you're right. I got to get this guy. Right. So I need to return the new slot. Thank you. And why doesn't it like that? Oh, I guess that's outside of the. Declare that sucker. Slot is equal to null. Okay, now I just want to filter out anyone that is, I don't have any null guys in there, and then we'll map it. We'll collect to a list. Alright, so let me format that so we can actually take a look at it. Alright, so all of that to basically grab the list of available card readers, and then we're iterating over those, and for each one that actually has a card in it, we're going to create a custom provider. And the way that we do that, we have to specify this basically format, or this configuration string that gives the name of the provider and a reference to the native library that it's using, and also the slot, which basically indicates the index. So when the way that it does handles your different card readers, it assigns each one of them a index or a slot number. So you have to reference that. So if I had two different card readers attached to my system, I would have slot 0 and then I'd have slot 1. That's why you have to put that there. Trying to do this manually is a real pain in the neck if you try to actually update that java.security file, because then you're like, okay, well, what happens if I switch my chords around, or how do you know which one's going to be which? So that. Okay, so that's how we install our providers. We give it the configuration string, then we invoke this constructor here, that's basically giving it a new instance of that bridge, that PKCS 11 bridge, and we add it to the list of security providers. So once that is done, we can actually start working with the contents of the cards themselves. So now, once I've got that, I'm going to invoke this other method here, this public static do a list of string. We'll actually get the card aliases from a particular I can't spell from a particular card slot. So given a particular smart card, tell me what aliases are on the card. And I need to say that throws an exception. All right. So now I'm going to get into working with a key store, because when you think of a smart card, you can think of that as basically being a key store, equivalent to a key store. So you can have your file-based key stores, which you've probably seen before. Well, smart card is basically just the same thing. It's just a key store. In terms of abstraction and how you deal with in Java, it's essentially the same. It's the same thing. So I'm going to use a key store builder, and so I just have to tell it to give me the appropriate thing here. So I'm going to tell it to give me an instance of a PKCS11 key store. I'm going to tell it what provider to use. So I got to say, okay, well, create this key store and use the provider that I just had registered. So we've got that information in our card slot. So I say get provider name, so that it will know, okay, well, what's the method that you're using to extract keys from this thing. All right. And in order to get past the fact that I got to enter in a PIN on to access the data on my card, I'm going to use this very handy little class, a callback handler protection. And the way that this works is whenever it needs your password, it'll basically provide you however you implement it. You could have like just a little window that pops up that asks you for your PIN. And so it basically does that kind of behind the scenes so that you don't have to think about when it needs to be, when that password needs to be entered. So in order to do that, I'm going to use an auth handler, which is another class that I'm going to implement. And what it's going to do is it's just going to pop up a little message box window, J option pane window, where you can enter in your PIN. So that's all it's going to do. It's going to be pretty simple. All right. So then, smart card key store. All right. So what that's going to do, it's going to instantiate the key store. So give me basically an instance of my logical representation of my actual smart card. All right. And then once I have that, it's fairly easy to just list off all of the aliases. All right. So collections, create a list. I can just one of the methods on a key store object is to get the list of aliases. So I can say aliases. And this actually returns an enumeration. So that's why I'm using this collections list to return a list. So pretty straightforward once you get past some of the initial complexities of registering things. And a lot of that stuff will just be kind of boilerplate code that you would hopefully put into some sort of reusable format, like a utils library or something like that. So what I need to do now is look at this auth handler so that I can actually access this. So let me create a new class called auth handler. All right, and this, so this is going to implement the callback handler interface. that down, and then use this to generate my methods. All right, so basically we just have to implement this one method here, this handle method. And what happens is we had already registered an instance of this auth handler class. Whenever it needs the password, it's going to invoke this method. And then at that point, we can enter in our smart card PIN. All right, so try to keep this a little bit simple. Callback and callbacks. All right, let me just say we're looking specifically for a instance of this password callback. Now, from what I've seen, there usually is only one callback passed in this array, but I guess maybe there's situations where you'll get more than one. And so what we're interested in is the one that is an instance of this password callback. So, so we just need to do a cast on that. Okay. All right, so now we've got what we need. So now we just need to present a window, allow you to enter in your stuff, and update the callback, and then it'll authenticate for us. So we'll do some very poor swing programming here, because we just need something basic. I don't know if you guys have ever actually seen me do any swing. We're always talking about Java FX. So, CJ label. All right, so we got our little J label, and we want a J password field. J password field, and not filed. I took typing, but it was a long time ago. All right, so we got our J password field, and now we just want to add that to the panel, or sorry, the label, and panel.add password. All right, it's pretty simple. Now let's get our options here. String, just want to OK, cancel. Cancel. Okay. All right, so now I'm just going to create the J option pane to pop up the window. In real life, you would probably want to make this a little bit more, presentable, but this gets the job done, I suppose. So pass in. We don't have any parent dialog. Stop that. Put this down here so you can all see it. And panel is the object that we're interested in. The title, we want our CAC pin required. And don't want it to show any special icons. And then just a plain message. And then null for the icon, options, and then we'll just go with the cancel as default. Okay. Now that'll show the dialog, and then we just have to check to see if option is equal to 0. Basically, if they click OK, then we just have to tell this callback object here, this password callback. Password callback. And there's a set password method on it. So we just have to grab the string from the password field, and that right there tells it to use that password when accessing whatever it is we're accessing, which in this case is the smart card. All right, so basically all we did was just display a simple window where we can enter in our password. The key thing here is the fact that we're telling this callback, okay, well, this is the password that you're looking for. It could be that you entered in something from the command line, whatever you want to do. It kind of leaves it up to you. All right, let me go back to here. So now I should be able to run this now, I believe. So now I'm going to try to run this, and we'll see if it works. All right, so we can run this. So we run. Hopefully it'll pop up a little dialogue for me. Yes, so there it is. So now I just put in my PIN, and then it can access those 3 keys. So these are just the aliases. The private key data you can't access at all. You can't print it out. You can't export anything. You can export a public key, however, if you needed that for like authentication and so forth. But anyway, that's just printing out the different aliases and showing you what's on the card. So if I had multiple readers, it would have gone through and listed all of those out. Any questions so far? Some of this is I know kind of detailed, but any other app? Yes, sir.
That security class that you add providers to, does that extract from that file initially and create some sort of table that you add more providers to?
Yes, that's exactly.
Add directly to that file, right?
Yeah. So this place down here where I added this provider, that is equivalent to going into. Did I even have this open? Yeah. That's equivalent to going into the java.security file and adding a line to this. And you can even see that it has some of the same information, although in this case there's no reference to a DLL because none of them needed a DLL. The only difference between ours would be that we'd have something like maybe like a number 11 or something, and we'd have Sun security blah blah blah, Sun PK CS 11, and then a reference to the whatever the DLL reference. So that's what it would look like if you did it statically. I have noticed the file is very finicky. Like if you get a space wrong or anything, it won't take it. It's very frustrating. Oh, I don't need to save it, do I? So
his question, I like to point that this file must be read by something, an initialization or.
yeah, it's read by the JVM when you start up Java, running kind of Java program. One of the things it does is it goes through and it reads that java.security file and populates the list of security providers.
So in most cases, we're programming on a system that we don't have admin rights to.
Exactly.
We have to do it the way that you've shown.
Yes, exactly. That's exactly why I was going through all of this, is because most cases you do not have admin privileges and you can't just go in and willy-nilly. I mean, as you can see, like if I try to save this, oh, you're not an administrator, So that's why it's not really a good solution. But most of the documentation that I've seen, that's the way they say to do it. And I'm just like, seriously? How? That doesn't even make sense. So anyhow, that's why this is a useful way of doing this. So the last thing that I wanted to show you, which we've already kind of done without knowing it, is let's say that you wanted to do an application that required a CAC to be able to access it. So whenever your users run it, you want to basically force them to authenticate using their CAC. So how would we go about doing this? Well, we've already done most of it. So let's just create a new class here called authentication. All right, and I'm going to copy some of the other stuff. So we'll let's grab this stuff here. I'm going to need that, and then we'll grab these other methods as well. Actually, let's copy that. Format. Okay. So we got same basic process. We've got to get the list of terminals available. What are the card readers? Which readers have an actual card inside of them? And once we determine that, and we are good to go. Static void main string. All right. So this will be a very simple main function that essentially will just pop up a window asking the user to provide their PIN, and if they do it right, if they give you a correct PIN, it'll say, yay, authentication successful, and if they do it wrong, it'll say, not successful. So, all right, so try catch this. So, once again, we're going to need to initialize our providers, or install the providers that we need. So that's going to go through and install the providers that we need for the smart cards we have installed. And then we're just going to pick the first one. Well, I only got one, but if you had multiple, you could have more than one here. So I'm just going to get the first card slot that got returned. All right, so now I'm going to do my key store builder key store dot builder. Get a new instance, and we want a PKCS instance. Right. So it's a PKCS11 instance, and we want to use the security provider that we registered for this card slot. So card.get provider name, and then we're going to use our handy dandy callback to do the authentication. So we do a callback handler protection. We pass in an instance of our auth handler, which just pops up that simple swing window asking you for a password. Okay. Now, once you try to instantiate the key store from the builder, it's going to ask you to authenticate. So an easy way of doing authentication is basically just to do exactly what I did here, and then just try to instantiate the key store, and that'll force you to basically log in. If an exception gets thrown, well, you know that they did not authenticate. If no exception thrown, then you're good to go. So in the case where everything goes expected, so we do show message dialog. We'll just do null and authentication success. Yay. So we're happy that they are all good to go. And if not, then we say no, they get denied. They don't get to use our awesome application if they don't put it in right. Okay, so that's just a few lines of code. I reused some of the stuff that I'd done before as far as installing the providers. Not all of that is the same. And what I'm doing is just grabbing the first card slot that gets returned. In my case, there will be only one. And then I'm building a key store based on the card, and then I'm trying to instantiate that key store, which will require you to enter in a PIN, and then it's going to pop up that little window. So let's see what that does when I try to run it. Okay, so I run. I will say this driver that I have, this OpenSC, is not as fast as the active client one. The active client one seems like it reads it much faster. All right, so let me put in a wrong pin first. Be gone, loser. Yeah, so it didn't work. So dang it. So now, let me try it and actually enter in the right pin. There we go. Oops. And then I get the authentication successful. So if you had an application that required any kind of authentication with this just simple method, you could do that pretty easily as just kind of the entry point into your application, so that when they go to do something, you could just ask them to authenticate, and if it's good, then continue. If not, exit the program or whatever you need to do. But I have a feeling that of all of the things we're doing, this is probably the thing you would most likely want to do, I imagine. I had another example that involved connecting to a CAC-enabled website and pulling down some information, but I decided against doing that one because I don't know if that would get me in trouble. So I decided not to do that one. But you can do that too. Also, I mean, it's the same sort of process. If you want to access a site that uses any kind of smart card for authentication, the only additional thing is that you now get into dealing with the certificates and the chain of trust and all that, which is pretty confusing. But it's a lot more detailed. So I figured, and I'm glad I didn't do it because we wouldn't have had time anyway. But anyhow, with what I've given you today, you've got kind of an intro into how to begin working with smart card technology, and from here you can kind of delve in a little deeper if you want, or maybe this is all you need to know. I'll make sure this code gets out because you'll definitely want to have that as kind of boilerplate for playing around with it. Okay. So any other questions? Yes, sir.
You mentioned a lot of problems with documentation, finding it, understanding it. Do you have any documentation you found that was actually useful, or somewhat understandable?
Most of it, sadly, it was on Stack Overflow. Just totally disjointed. If you look at any of the tutorials that are on Oracle's pages, they all basically do the same thing. Start with your file-based key store, update your java.security file. So the assumption always seems to be that you're taking this one approach, which just doesn't work for most people, I wouldn't think. But so yeah, a lot of it was just searching around. How do I, once I realized what the right question was to ask, I found a lot of answers on Stack Overflow. But hopefully, knowing some of what the important classes are, you can at least Google the correct, question for what you're trying to do. But yeah, it's very disjointed for some reason. And I would say go look on Safari Books, but that's no help either. You won't find anything on Safari Books either about how to do this stuff. So it's I'm not sure why it's such a big secret, but it is.
So the tutorial approach makes some assumption that at the start of the session, all the card readers you're ever going to use are already installed and all your providers are in the file. Here you didn't assume that, but would it be fairly safe to just run your install providers once per session?
Yeah, unless you, yeah, right. Right, so the question was, what if, is it a safe assumption to assume you've got all the card readers set up when you run the program? I think in most of the time that's probably true, unless you want to make your program, a little bit more awesome and make it so that, it detects it or can actually run it, because you could totally do that too. You could run a check to see, well, have they removed it, or is it still valid, So you could run those types of checks, but doing it dynamically just seems like a lot safer an option, because I mentioned also that as part of the configuration, you actually have to specify a slot index. So the Java runtime environment, the JVM, if you have multiple card readers plugged in, setup, it assigns each one of them an index, a zero-based index. Well, if that's statically entered into a file, your java.security file, and you move those, you unplug them and then plug them back in, they may not be the same index. So you could end up, with some pretty messed up results, depending on what you do. So that's kind of my reasoning behind why you wouldn't want to do it that way. I just don't know why that was assumed to be the way to do it. I mean, maybe they just didn't want to have to deal with the complexity of setting it up. But although it's not even really that complex. But anyway, so it makes no sense to me. But there's very little documentation out there. Maybe you'll be luckier than me in finding it. But having something to start with will definitely move you further. Because literally, it took me like 6 months to figure out how to do all this stuff, just to figure out how to access the information on the cards. And I mean, it was definitely like finding a needle in a haystack. So, any other questions? Where you? Okay. Well, thanks for coming out, and hope you picked up something. It was a lot of detail. But, thanks a lot, and no meeting next month, I guess, because Andy's gonna be at Java 1. So, all right, y'all have a good one.
So I really do have more questions.
That's okay. That's good.
The stuff you were going to talk about, the accessing a tech-enabled website. So